Hello everyone, in this video we will discuss the question number 42 of GATE 2021. So in a chemostat with a dilution rate of 0.8 hour inverse, the steady state biomass concentration and the specific product formation rate are 8 mole per meter cube and 0.2 mole product mole biomass inverse hour inverse respectively. So basically the specific product formation rate is 0.2 mole product per mole biomass per hour and the biomass steady state concentration is 8 mole per meter cube. The steady state product concentration is yet to be found in the unit of mole per meter cube. So here we are asked to find the concentration of the product at the steady state. Steady state biomass concentration is given 8 mole per meter cube and specific product formation rate are given 0.2. So now if we want to solve this, so firstly if we do the product balance, so suppose it is a chemostat and where the volume is constant, so there is a feed which is flown at a rate of F, and in the feed suppose there is biomass concentration x naught, substrate concentration S naught and product concentration P naught. But the thing is, if our feed is sterile, then x naught will be 0, right? There will be no x naught, and in the feed there is no product, right? Product will be formed inside the chemostat. So ideally, generally in the feed of the chemostat there is no product, so P naught will be also equals to 0. And now there will be a output. In the output you will see have product, substrate, right? So if we do the product balance in the chemostat, then input plus generation equals to output plus accumulation plus consumption. So in the input we can write Fp naught, generation we can write Qpxv, in output you can write Fp, but at the steady state accumulation will be 0, right? And in the chemostat there is no consumption of the product will be formed. You will supply the substrate, right, in your feed, and when the substrate will come and it will get in contact with the biomass or X, then this X will be they will grow by using this substrate and they will make product, right, in the chemostat. So product will be produced, it will not be consumed. So product will always be generated, it will not be consumed. So consumption is also equals to 0, accumulation is 0 because it is a steady state, because all the informations are in the steady state. So in the steady state accumulation is 0 and consumption is 0. So basically input plus generation equals to output. So input we can write Fp naught, generation Qpxp, and output Fp, right? And as I already mentioned that in the feed there should not be any product, right? Product will be generated in the chemostat, so P naught will also be 0. So P naught, which is the product concentration in the feed, is 0, right? So this thing will also be 0, right? X is the biomass concentration in the chemostat at steady state, which is given as 8 mole per meter cube. P is the product concentration in the chemostat at the steady state. Qp specific product formation rate 0.2 mole product mole biomass inverse hour inverse. So and F is the feed flow rate, V is the working volume of the chemostat, D equal to dilution rate, which equals to F by V. So here you can see that in the input it is Fp naught, which is the rate of product input, but later we saw that P naught equals to 0, so this term will be 0. So we will be remaining with the Qpxv equals to Fp. So in this equation, as P naught equal to 0, so we can rewrite the equation like Qpxv equals to Fp. Qpxv is the product generation rate of product generation. Why? Because Qp, what is the definition of the Qp? It is specific product formation rate. That means, so Qp is defined by the mole of product mole of product generated by unit mole of biomass, right? So 1 mole of biomass, so this is basically the calculation or the amount of the product which will be generated by using 1 mole of biomass per hour, right? So amount of product generated, or mole of the product generated by using 1 mole of biomass in 1 hour. This is your QP. So if QP is given, then product generation rate will be QP into X into V, right? Because QP will give you the information that 1 mole of biomass, how much product it will generate. But you have the biomass concentration in the chemostat at X. So if 1 mole of biomass will generate this much of product, which is QP, then X mole of biomass will give you QPX, right? QPX amount of product, and here X is the concentration, right? X is the concentration, which is actually here it is mole by meter cube, right? X is mole by meter cube. So here again in the QP definition, 1 mole of biomass it can produce 0.2 mole of product. This is nothing but QP. So now if you know the QP, so now you know that 1 mole of biomass can produce 0.2 mole of product. So now in your chemostat, the biomass concentration is X, right? Which is 8 mole per meter cube. So biomass concentration is given X, chemostat volume is V. So how much mole of biomass is there? V into X. X is mole per meter cube and V is the unit of volume, so meter cube. So V and V into X, this is the mole of biomass in the chemostat, right? So if 1 mole of biomass can produce QP mole of product per hour, then Vx mole of biomass will produce QP into Vx amount of or QP into Vx mole of product per hour. Again, 1 mole of biomass can produce QP mole of product in 1 hour. So Vx mole of biomass, because X is the concentration, V is the volume, so mole is Vx. So Vx mole of biomass will produce QP into Vx mole of product per hour, right? Which will be equal to Fp. F is the feed flow rate, and if the input feed flow rate is F, then the output feed flow rate will also be F, right? So output will be F into P, right? P is the product generated, product concentration in the chemostat at steady state. In the feed there was no product, P naught equals to 0, right? P naught equals to 0, there was no product. And in the chemostat, by using the biomass, the product has been formed and the product concentration is P at the steady state of the chemostat. So this much product has been generated, right? Or I mean, this much product generated, and this much product will come in the output, right? So that's why it is Fp. P is the concentration, F is the flow rate, right? So the product output rate is Fp. Now, so from this equation, as we can rewrite it as Qpxv equal to Fp, then you can also write Qpx equal to F by V into P, and F by V equals to dilution rate, which is 0.8 hour inverse. So in place of F by V, we can write D. So Qpx equals to dP. So P equals to Qpx by D. Qp is given 0.2, right? X is given 8 mole per meter cube, right? By D you need to calculate. D equals to F by B. F is feed flow rate. Feed flow rate is so actually here there is no need of calculating feed flow rate, because here it is given as the information of the D or dilution rate, which is 0.8 inverse. So D or dilution rate is given as 0.8, right? So again, P equals to Qpx by D. Qp equals to 0.2 mole product, mole biomass inverse, hour inverse. In case of X, we can write 8 mole per meter cube. by D. D is 0.8, our inverse is given. So the P will be 8 into 0.2 by 0.8, unit will be mole per meter cube. So it will come 2 mole per meter cube. So the product concentration will be 2 mole per